but only one thing is given, that which is clearly said that E does not give tolerance test and does not reduce failing solution. From this, what should strike in your mind is that E has to be a ketone, because ketone does not react with this tolerance test as well as the failing solution, but aldehydes do react it. Now, because we are being given that E does not react with tolerance and all, so therefore E will be a ketone first of all. And the second indicator which is being given as, the molecular formula of E. So basically in these types of questions, where the information about the first reactant is totally absent, entirely absent, in that case we have to pick up the information from the middle products, if you are not being given the information about the beginning product. So therefore what we will assume first of all is that E is a ketone, that too has a molecular formula C3H6O. Now this molecular formula, that is C3H6O, is basically of the types CnH2nO, and this CnH2nO actually represents the function groups as ketone and aldehyde only. But we have the strong reasons to believe that in this case this compound E cannot be aldehyde, because it is not reacting with the failing solution or the tolerance reagent either. So therefore you have now the strong reasons to claim that E will be a ketone first of all. Now, because it is also being given that the E has the molecular formula as C3H6O, and E is also a ketone, so therefore what you will straight away say, that a ketone with the 3 carbon, that it is only the one ketone which is possible, that is CH3COCH3, which is nothing, it is the acetone. So the first point which you made out over here is that E which has the molecular formula C3H6O does not give tolerance test, does not reduce failing solution, but forms hydrazone. So therefore E has to be a ketone. Now because E has got 3 carbon atoms, due to which we straight away can define the structure, or we can straight away define the product, that is E will be acetone, which has a molecular formula CH3COCH3. Now further information which we are being given is this, that B is also B on heating with the calcium hydroxide. Now when you heat basically with the calcium hydroxide, that reaction is known as the pyrolysis. Now because B is giving you E, so E has to be a ketone first of all, and you are being said that, now important thing over here is that you are being given the product of the pyrolysis, but you need to tell what will be the structure, what will be the structure of the raw material from which acetone has been formed. Now in the pyrolysis reaction, what do we majorly have is this, that if I broadly say, then we have something like, we have R1 C double bond O, that is whole twice Ca, and we have R2 C double bond O whole twice Ca. Now when you carry out the pyrolysis, so what we get is the R1 C double bond O R2. Now because we have E as the product which is ketone, and in ketone we know that there are 2 R groups, and that too in the case of acetone they are similar. So therefore if you map this product with the basic structure of the product of the pyrolysis, you will straight away say that R1 and R2 are nothing, they are the CH3. Because in the ketone formed over here, that is CH3COCH3, we have two R groups which are same. So therefore in these two R group will also be there in the calcium salt of the carboxylic acid. Another point over here is that B on heating with